Hello student, today I am going to discuss very important topic is nothing but the states of matter. In the states of matter, you need to know first few things. What is that? So let us focus on states of matter. In the states of matter, in the basic concept of chemistry already you know, there are three states of matter is very important. One is gas or vapor, another one is liquid and another one is solid. First things you need to know very nicely this concept. Whenever the solid is there, the intermolecular or interatomic force of attractions will be very high. They will be very close packed in a regular fashion. This is nothing but a solid. Intermolecular force of attractions, intermolecular or interatomic, intermolecular force of attractions will be very high. The intermolecular force of attractions is very high, very high. So because of high intermolecular force of attractions, they will be very close to each other and they will be close packed in a regular fashions. And now when you will give little temperatures, suppose you are supplying thermal energy. When you are giving thermal energy, then you look at, that means you are supplying the heat or increasing the temperatures, then what will happen? The kinetic energy of the molecule will increase, they will go little far apart. When they will start going little far apart, they will be converted to what? Liquid state. In liquid state, picture will be little far apart, will be like this. So that is nothing but a liquid. Because of the increment of the temperature, by putting the thermal energy, the molecules get the more kinetic energy. When the molecule will get the kinetic energy, what they will do? They will start going far apart. They want to move away. When that will happen, solid will be converted to what? Liquid, and this phenomenon is called as a melting point, my dear. And now this liquid, when you will supply more thermal energy, then what will happen? The liquid will start boiling and then the liquid will convert it to gas or vapor. And now in the gas or vapor, the molecules will be random to each other. They will be far away to each other. They are in a random motions. They will be random to each other. So that is why you have to understand these things. Whenever you are mentioning any states of matter, you have to mention at room temperatures or at a particular temperature and pressure you have to mention. Suppose I am telling at 25 degrees centigrade of temperatures, 25 degrees centigrade of temperature or 298 K, same thing, centigrade plus 273 is nothing but a temperature in Kelvin scale, or 298 K, and I am telling 1 atmospheric pressure. That means the atmosphere exert 1 atmospheric pressure. At that conditions, the sodium will be nothing but a which state? Sodium metal will be there in solid state, and then water will be there in which state? Will be there in liquid state. Nitrogen will be there in which state? Gaseous state. Hydrogen will be there in which state? Gaseous state. So these are the things you have to understand. Whenever any states of matter you are mentioning, you have to mention the temperatures and the pressure. Because you know, if I increase the temperature around 500 degrees, then sodium will be converted to what? Liquid. It will not exist as a solid. So that is why when you are mentioning the states of the matters, is nothing but mentioning the temperature and pressure is very important. Otherwise there is no meaning, because when you are mentioning anything solid, you have to mention at what temperature and what pressure, because they will be interconvertible to each other. When you will increase the thermal energy, that means when you will increase the temperatures, the solid will be converted to liquid as because of increment of the kinetic energy. Because the solid means intermolecular force of attractions will be very high, they will be very close to each other. When they will be very close to each other, there will be closeness of packing will be there. And then if you increase further temperature, the liquid will be converted to what? Gas or vapor. So that is why this phenomena will arises over here itself. Now once you understand these things, then you need to know few things over here. After knowing this, you need to know the different types of force of attraction. Depending on the force of attraction, when we can say when the force of attractions is very high than thermal energy, then we can say the state will be nothing but a what? Solid state. when the force of attraction will very, very high, it will dominate like anything over the thermal energy, then the state will be which state? Solid state. When the force of attraction little dominate, so only little high, force of attractions, when it will little dominate than thermal energy, so then what will happen? The solid will be converted to what? Liquid state. And then when the force of attractions is negligible, almost is nil, and the thermal energy is very, very high, thermal energy will be very, very high, then what state we will call it as a gas or vapor state will be exist over here. So that is what you have to understand clearly. When the force of attractions will be very, very high, then which state? Greater than the thermal energy, then solid state. When force of attraction little high compared to thermal energy, which state? Liquid state. When the force of attraction is negligible and thermal energy is extremely high, then which state? Gaseous or vapor state. So that is what you have to understand these things. Then we need to know what are the different types of force of attraction is present. So let us focus the types of force of attractions. Different types of force of attraction, especially van der Waals force of attractions. Let us focus on this. Different types of force of attractions. Different types of force of attractions. So then different types of force of attractions. Different types of force of attractions. Force of attractions. Different types of force of attractions. So then when we need to know different types of force of attractions, then what you have to do? So then first of all you look at, there are few force of attractions we have to study. The first one is dipole force of attractions. Dipole force of attractions. Dipole force of attractions. If you look at in dipole force of attractions, what is happening there? Here you have to understand nicely. So if there are any molecule is there which is a dipole in nature, like that for our example we can take it like the water molecule or HCl molecule. Suppose the HCl molecule is there. The HCl molecule, chlorine has a more electronegativity than hydrogen. So that is why the bonded electron pair will be taken by chlorine. As because of electronegativity is nothing but ability to attract the electron pair towards itself in a bonded conditions, whereas electron affinity is nothing but a ability to take the electron in a free state. Both is essentially ability to attract the electron. One is in bonded condition, one is in free state phenomena. So that is why this chlorine will be what? Del minus, hydrogen will be what? Del plus. Another HCl molecule, the positive part will come this side, like this scenario. Then in between this del plus and del minus, plus minus, there is a force of attraction will be there. This is the electrostatic nature of this force of attractions. And now suppose the distance between the two dipole, I am taking the r. So then the force of attraction, suppose if it is F will be proportional to 1 by r to the power 6. So that means force of attractions will be proportional to 1 by r to the power 6. R is the distance between the two dipole. So that means the dipole force of attractions will operate in a polar molecule, polar covalent molecule. Got the point? In a polar covalent molecule, why that polarity will arises? Due to difference in electronegativity. Got the point, my dear student? So this is nothing but a dipole force of attractions. The second one is nothing but a dipole-induced dipole force of attractions. Dipole-induced dipole force of attractions. Dipole-induced dipole force of attractions. Force of attraction. In dipole-induced dipole force of attraction, what is that, my dear? In the dipole-induced dipole force of attractions, already you need to know what is that. That is nothing but if there are one molecule is there dipole like HCl, where this will be del plus, this will be del minus, as the chlorine is a more electronegative in nature. So that is why here if you keep the helium molecule like this, then in the next step, when there is a negative charge is there, it will repel the electron from the helium. So then electron will go more opposite side of the helium because of the repulsion of this partial negative charge. So then when electron will move towards the opposite side, here there will be developed one del plus and this side will be del minus. This is a induced dipole. This is a induced dipole, and this dipole is already developed because of electronegativity difference in a bond. Now there will be a force of attraction between dipole and induced dipole, and the distance between these is r. So then the force of attraction here also 1 by r to the power 6 distance between the two dipole. There will be one dipole molecule will be there, polar molecule will be there, which induces the dipole in a non-polar molecule. Then what will happen? Because of that, the induced dipole will be generated over here, and then dipole induced dipole force of attractions will operate, and then we will get there will be some bond will be there. Interaction means the force of attraction means bond. That bond will be the weakest bond because it is a van der Waals force of attractions. Now you look at the next category. This is nothing but a what? Induced dipole force of attraction. Induced dipole force of attractions. In the induced dipole force of attraction, what will happen? Suppose I am taking here one helium molecule, like here one helium molecule, here another one helium molecule will be there, like this. Helium has a 2 electron, so that is what I am writing here, the 2 positive charge, and here there will be 1 electron, and here there will be 1 electron negative charge. And now this presentations is nothing but a time average presentation. Very one moment what will happen, you know, this 2 electron maybe partially will be more in one side. It will be like that scenario will come. And then this side will be more positive charge. This scenario will come. Just 2 electron will in one moment. It is very momentary arrangement. And if I take the time average, then only this ideal picture will come. And then next moment in this helium, when this induced dipole is developed over here, this is nothing but a time average dipole, that is why they are calling this is the induced dipole. Then what it will do? Immediately the positive will attract the negative, and immediately this scenario will come into the picture. Here also this induced dipole will induce the dipole in another molecule. This is the induced dipole. So then in between distance also will be nothing but r. So then induced dipole here and induced dipole over here. Force of attraction will operate, electrostatic force of attraction. That is called as the induced dipole force of attraction, or other name of this one is a London force of attraction. Here also force of attraction is proportional if 1 by r to the power 6. All cases 1 by r to the power 6. Only here one category is there. If stationary polar molecule is there, then only A proportional to 1 by r to the power 3. Otherwise all cases the force of attraction is proportional to 1 by r to the power 6. So these are the different types of force of attraction. Rather than another one category is there, already I discussed in a chemical bonding, hydrogen bond. This hydrogen bond also van der Waals force of attraction. This is a fourth one if I say. So that means 1, 2, 3, 4 all are van der Waals force of attractions. Among these van der Waals force of attraction, hydrogen is the strongest and induced dipole is the weakest, and the order will be nothing but already write down. Hydrogen bond is greater than dipole force of attraction is greater than induced dipole induced dipole force of attraction greater than induced dipole force of attraction. These are the different types of force of attractions. What you need to know over here. Got the point, my dear? Is clear, everyone? So now if you understand this force of attractions, after that depending on the force of attraction, different states of matter will exist, and the solid state we will study in +2 separately, and in this chapter specifically mainly we will study the gaseous state, and in the last we will discuss few things regarding the liquid state. These are the things you need to know in this chapter. So let us focus now on the gaseous state. So that is the different force of attraction. Depending on the force of attraction, the states of matter will exist. When the thermal energy will be high, one state will be converted to other state. Already we discussed these things. And now let us focus on the gaseous state. In the gaseous state, you need to know few things. When the gas will come into the picture in a cylinder, so then you need to know to define the states of matter, you need a certain parameters. So that means now our focus is gaseous state. Focus is gaseous state. And in gaseous state, to define a states of the gas or the states of the matter, few parameters are required. What is that? To define the states of the gases, few parameters are required. Few parameters are required. What is that, my dear? That is nothing but a pressure, P for pressure, T for temperature in Kelvin scale, temperature in Kelvin scale, and then V for volume of gases, and then N is a number of moles. So these are the parameters are required to define a states of the gases. And now we have to see what are the interrelations between them. That is nothing but a different gas law, Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's law. We will explain one by one with their plot and all those things we will go through. Now, very simple way I told, to define a states of the gases, there are certain parameters are required. What is that? Pressure, temperature, volume, number of moles, and their interrelation is nothing but a gas law. Then we will focus for the gas law. And pressure, you need to know different in terms of a atmosphere. 1 atmosphere, you need to know 1 atmosphere is nothing but a 760 millimeter, is nothing but a 760 torr, is nothing but a 76 centimeters of mercury, is nothing but a 1.013 bar. So all these things you need to know over here itself. Or is nothing but a 103.5 10 to the power 3 pascals. All these interconversions you need to know regarding over here. Like the volume will be there in what? It can be, volume will be there in liter, volume will be there in meter cube. Suppose they are telling 10 to the power 3 meter cube, is nothing but a 10 to the power 3 decimeter cube, is nothing but a, this is nothing but a 1 decimeter cube means 1 liter. This is nothing but a 10 to the power liter, and then this is nothing but a 10 to the power 6 centimeter cube. So these are the conversions you need to know very well. So that is what all those things you have to know in terms of a volume also. So that means these are the parameters which are required to define a states of the matters, and their interrelation is nothing but a produces different gas law. So then once you understand these things, let us focus for the different gas law. The first law what we need to study is nothing but a Boyle's law. So what is Boyle's law? Everybody knows. If you know the relation, you can make the statement. So that is why the knowing the relation is very, very important, and then from there the different types of plot. The first gas law is nothing but a different gas law we are now going to explain. When first one is nothing but a what? Boyle's law. In Boyle's law, what is scientist Boyle is telling like that Boyle's law? Scientist Boyle is telling the mathematical expression, pressure is inversely proportional to volume. Now when temperatures and number of moles is a constant, that means Boyle's law is statement, then what we can make a statement, because if you know this mathematical form you can make the statement. That means at a constant temperature for a fixed mass of gas, number of moles is constant, means the amount of gas is constant. So that is why at a constant temperature for a fixed amount of a gases, pressure is inversely proportional to volume. That is nothing but a Boyle's law. So that is nothing but a Boyle's law. That means at a constant temperature and at a fixed mass of a gas or fixed amount of a gas, pressure is inversely proportional to volume. So that means if pressure is increases, volume will be what? Decreases. If pressure will increase, volume will decrease, or else if volume will increase, pressure will decrease. These are the important things you have to need to know over here from this Boyle's law. Got the point, my dear? So then if you remove this proportionality, then we can write down P K into 1 by V. You will get over here, because when you will remove this proportionality, you have to bring certain constant. This K is nothing but a what? Proportionality constant. Proportionality constant, you know very well from mathematics. Proportionality constant. And then we can write down PV will be equals to what? K is nothing but a constant. Thermodynamics already we prove it. PV to the power gamma equals to constant. This is for the isothermal process. Got the point, my dear student? PV equals to constant. So then when PV equals to constant, then we can write down P1 V1 will be equals to P2 V2 will be equals to P3 V3 will be equals to K will be equals to constant. With this they can give a mathematical problem. They will give you two different pressure and one volume, they will ask the another volume. Then you have to apply P1 V1 will be equals to P2 V2. Be careful, the unit will be in a same unit. Maybe one pressure they are giving in atmosphere, other pressure they will give in bar. You have to convert in a same unit. You got the point, my dear student? So that is why this is nothing but a Boyle's law. Later I will come the plot after explaining all the gas law. In together I will show you the different types of plot, my dear. Got the point? So then this is nothing but a Boyle's law. Then what is the Charles law? The Charles law is very simple, my dear. The Charles law is telling whenever any gas is there at 0 degree centigrade, or the 0 degree Kelvin means minus 273 absolute 0. So whenever any gas will be there in 0 degree centigrade, if you increase 1 degree centigrade of temperature or if you decrease 1 degree centigrade of temperature, whatever the volume is there at 0 degree centigrade, with respect to that volume, 1 by 273 part will increase or decrease. That is nothing but a Charles law statement. And then Charles law, here itself we are writing the Charles law. The Charles law is mathematical expression we will come. Before that you need to know Charles law, what they are telling. Suppose at 0 degree centigrade, volume of gases is nothing but a V0. And now if you increase 1 degree centigrade temperature, increase 1 degree centigrade temperature increases, 1 degree centigrade temperature increases, then volume will increase how much, my dear? Volume will increase like that, V0 by 273. That means 1 degree increase, that is why V0 into 1 by 273. Now the new volume will be nothing but how much? Now new volume will be nothing but how much, my dear? Will be equals to V0 plus V0 into 1 degree centigrade increase by 273. This will be the new volume. Initial 0 degree was there V0. When you will increase temperature 1 degree, how much will increase? V0 into 1 by 273. That means the whatever original volume was there 0 degree, with the respect to that one, 1 by 273 will increase or decrease. Suppose if you decrease the temperature, then it will be V0 minus V0 into 1 by 273, like that, my dear. And now suppose I am increasing the temperature, T degree centigrade temperature increase. Temperature increase means now new volume will be nothing but how much, my dear? New volume will be equals to V0 plus V0 into T degree centigrade by 273. For 1 degree centigrade how much? 1 by 273. So T degree centigrade how much? T by 273. You got the point, my dear student? So that is why if you take the now common V0, then you will get 1 by 1 plus 270 T by 273. Now you look at V0 equals to these things 273 plus T degree centigrade. You will get this 273 plus T is nothing but a temperature in Kelvin scale. And now this new volume I am telling V, capital V. So this things is nothing but a V0 this, then we can write down V will be equals to V0, and this things is nothing but a capital T by 273. And now if you look at V0 is at 0 degree centigrade, this things is a constant, and 273 is also a number, it is also a constant. So then we can write down V is proportional to what? Temperature in Kelvin scale when the pressure and the number of moles is constant. So that means for a fixed amount of a gases at a constant pressure, the volume is directly proportional to temperature in Kelvin scale. That is nothing but the Charles law mathematical expressions. You got the point, my dear student? So that is what you have to understand. So that means once you know the relations, mathematical relation, you can make the explanations. At a constant pressure for a fixed amount of a gases, the volume of the gases is directly proportional to temperature in Kelvin scale. This is nothing but a Charles law. So then once you understand these things, then from the Charles law, what we can write down? Let us look at from the Charles law, what we can write down. From the Charles law itself, we can write down like this way, my dear. If you focus over here, from the Charles law, what do we know? Volume is directly proportional to temperature from the Charles law. If you remove this proportionality, then we have to bring certain constant. That constant is a proportionality constant, which is K. Already like the Boyle's law, that time also we discussed. And then we can write down V by T will be equals to K is nothing but what? Constant. So then from there itself we can write down itself that general expression V1 T1, V1 by T1 will be equals to what? V2 by T2 will be equals to what? V3 by T3 will be equals to K is nothing but a constant. Will be nothing but a what? Constant, my dear. Got the point? These are the general relations. So that is what you have to understand. This is coming from the Charles law. Now, once we understand the Charles law, then the Gay-Lussac's law is very simple. The same way it is coming, directly we are writing the Gay-Lussac's law. What is Gay-Lussac's law is saying? The Gay-Lussac's gas law is saying like that. Pressure is directly proportional to temperature when the volume and number of moles is constant. That means for a given volume of gases and for the fixed amount of gases, so pressure is directly proportional to temperature in Kelvin scale. So then from here itself also we can write down P will be equals to some constant into temperature if you remove the proportionality. So then P by T will be equals to K is nothing but a what? Constant. And then if I put the general expression, P1 by T1 will be equals to P2 by T2 will be equals to K will be equals to what, my dear? Constant. So that is nothing but a, this is also another expression for doing the different types of problem, like V1 by T1 will be equals to V2 by T2, P1 by T1 will be equals to P2 by T2. Got the point, my dear student? So these are the different way to do the problem. This is a Gay-Lussac's law. So as of now I explain Boyle's law, Charles law, Gay-Lussac's law. Then we need to know Avogadro's gas law. What is Avogadro's gas law? So let us focus on Avogadro's gas law and from there the ideal gas equation. So then if you look at the Avogadro's gas law, already in a basic concept of chemistry we explained that one. What is Avogadro's gas law? If you look at this, Avogadro's gas law is saying like that volume is directly proportional to number of moles. So that means Avogadro's gas law, Avogadro's gas law, what is telling? Volume is proportional to number of moles when pressure at temperature is a constant. So then that means we can make a mathematical expressions at constant temperature and pressure. So if I take it over here, then you will understand, remove this proportionality, some constant into number of moles. So then immediately we will get V by N will be equals to K is nothing but a what? Constant. Or in general expression V1 by N1 will be equals to V2 by N2 will be equals to K will be equals to what, my dear? Constant. We are getting these things. We are getting this one, my dear. So you have to understand these things very clearly. So that means at a constant temperatures, so if I say from here statement, at a constant temperature and pressure, the equal volume of two gases contains equal number of moles or nothing but equal number of molecules. So that is the statement of Avogadro's gas law. Volume is proportional to number of moles. So that means when pressure and temperature is a constant, that means at same temperature and pressure, equal volume of two gases will contain equal number of moles, nothing but equal number of molecules. That is Avogadro's gas law. So then if I combine these three gas laws, one is Boyle's law, P or V is proportional to 1 by P. This is nothing but a what? Boyle's law. This is Boyle's law. And then we can write down V is proportional to temperature. This is Charles law. This is Charles law. And then V is proportional to number of moles. This is Avogadro's law. Avogadro's law. This is Avogadro's gas law. And then if you look at, if I combine with these things, then we can write down V is proportional to NT by P. V is proportional to NT by P. So by combining, this is combining 3, combining above 3, we will get these things. So then if you remove this proportionality, you have to bring certain constant. That constant is a universal gas constant, NT by P. So then we can write down PV will be equals to A0T, ideal gas equation, when P is the pressure of the gases, V is the volume of the gases, N is the number of moles, T is the temperature in Kelvin scale, R is a universal gas constant, and the R value will be equals to 8.314 joule Kelvin inverse mole inverse, and in liter atmosphere 0.082 liter atmosphere Kelvin inverse mole inverse, in calorie 1.99 calorie Kelvin inverse mole inverse. So these things you have to remember, the R value in joules, in liter atmosphere, and in calorie is nothing but a 1.99. You can take it as a 2 for calculation, make it easy. So that is what you have to understand. So that means the any gases at all temperature and pressure which is obeying Boyle's law, Charles' law and Avogadro's law, that gas is considered as a ideal gas equation, my dear student. Got the point? So that means at any gas, if at all temperature and pressure maintaining these 3 laws together, then that gas is called as the ideal gas. But in reality, later we will study, there is no gas is there in this ideal. All are nothing but a real gases. In a certain condition, they behave like a ideally. That's all it is. So now I hope you understand this basic gas law, what is discussed over here. And the next class, I am going to discuss the different plot related to different gas law and that type of questions, what type of questions they used to ask from that plot, I am going to explain in the next class. And then only we will proceed for the Dalton partial pressures law, then Graham's law of diffusions. One by one we will proceed accordingly, my dear student. Thank you very much. Thank you all.